Hi guys, welcome to my channel at Eazy Surveys, where I make survey practices easier and educative. Here in this training video, I want to show everyone on how to process static data. Okay, so the static observations or static survey is one of the concepts under the Global Navigational Satellite System, which is the GNSS surveys. All right, so you should check online sources and as well as textbooks, survey textbooks, to have a better theoretical understanding of what static observations is all about and how it is being carried out. However, this training aims to show everyone on how to process the observed static data. So your data is expected to be downloaded from the receivers, and it is expected to be in a folder, and it is best way is arranged as you are seeing on the screen. So you should have your base data saved in a base folder. All right, so this is RINEX, and these are the observed files, okay, from the receiver. And here rover folder, here the rover data, and if I open the RINEX, these are the observed files. Okay, so for easier processing, your data should be saved this way. All right, so when you have your data downloaded from the receivers, the first thing to do is to open the processing software. So the course of this training video, I'll be using the Tersus Geo Office or Tersus Geomatics Office. So if you're in need of this software, I'll be dropping a video in subsequent times on how to download and install freely. All right, for those who are just joining us on this channel or those who are returning viewers, stay tuned by subscribing to this channel and turning on your notification on this channel. Turn on the notification bell so that you can get updated immediately I dropped the video. Thank you. So the first thing now is to launch into the processing software, and you click yes. So the process and the steps is just as highlighted at the left hand side as you are seeing on the screen. So the first thing now to do on the software is to create a project. All right, so you click on new project. So here your project, you have to name it. So I'm just going to name this YouTube. Okay, YouTube. Then the directory, which is the path you want your project to be saved, so I'm just going to save it under my YouTube folder. All right, then that is just the first thing to do when creating projects. Then you click on OK, you click on yes. All right, so here you do not need to do anything much. Okay, then you click on OK. So the next thing is to create your coordinate system. Okay, so all GPS receivers, all GNSS receivers observe data from the satellite on the source ellipsoid, which is generally the WGS ellipsoid. All right, so in the course of this training video, I want to process my data into a particular target system, target reference system with its own ellipsoid. So I'm in Nigeria and my data is collected here in Nigeria. If you're in other parts of the world, you should have a better understanding of what target system you are interested in. All right, so where I observe my data is somewhere in the western part of Nigeria, which uses the UTM-MENA system. All right, so here is where I am going to add my predefined coordinate system, then do the editing, just like what I want to do now. So you're expected to do the same thing if you are using the same target system as mine. If you are not using the same target system as mine, you are going to see the options you have to make use of. All right, so the next thing is to click on add predefined. So here these are the different parts of the world. So you can see Central America, Asia, Eastern Asia, Europe, and etc. All right, so Nigeria is under the North Africa, so you click on that. If you're in Nigeria processing a data from Nigeria, then you click on Nigeria. So these are the different UTM. All right, so these are predefined. It's not the exact target system. Okay, so I'll be using the UTM. All right, WGS zone 31. Okay, however, I want to use the UTM-MENA, so I'm still going to show you how to do the editing as we forge ahead. Okay, so you click on this if you are in zone 31, which is the western part, if you are in zone 32, the eastern part, and zone 33, the northern part. Okay, so there is other side of the grid system we use here in Nigeria. We use the NTM, the Nigerian Traverse Mercator, which is another local system on its own. Alright, so in subsequent video I'm going to show you on how to set up that for the NTM. It's quite different. As you can see, there is no NTM option, so I'm going to show you on how to set up for the NTM in subsequent videos. However, let's forge ahead with the UTM MENA system. Alright, so when you click on the zone of interest, you click on open. So here is the default setup. Okay, and we are not done because the target system is the MENA. Okay, so the next thing to do, okay, you leave the source ellipsoid, which is the GPS raw data ellipsoid, then you come to the target ellipsoid and edit that, okay, to CLAC 1880 RGS by clicking on this drop down shadow arrow here. So you are going to see different ellipsoids. Alright, so these are different ellipsoid of interest. So you scroll down to CLAC 1880 RGS. Okay, then you click on that, it's going to appear here. Then the next thing is come to projection. So under projection now, because we have used the predefined UTM zone 31, so we can already have and see the central meridian, which is 003. Okay, so there's nothing to do here. However, if you want your target system to be the NTM grid system, this is the stage whereby you have to choose the projection system of interest, and that is going to be the Mercator. Alright, so here you are now going to edit all this to the exact parameters of the NTM system. However, I am using the UTM MENA and not the NTM MENA, so I'll just leave it at the default. Okay, so the next thing is to come to convert. Here is where you are to choose the transformation parameters. You have to edit the rightful transformation parameters from the source system to the target system. What I mean is that from the WGS84 to the target system of interest, which in this case is the UTM MENA. So here, if yours is not on Bossa Wolf model, you change it to Bossa Wolf. Alright, so here I have already the parameters, the transformation parameters. The X for the general UTM MENA is 92, while the Y is 93, while the Z is minus 122. Then the RX, RY, RZ, which are the rotational elements, okay, is 000, while the K, which is the scale factor, is 1. Okay, is 1. Then the next thing is to come to plane. So here on plane, you do not do anything, you don't have anything to edit. The height fitting now is where you are going to choose the geode model, so that you can have your heights, okay, with respect to the mean sea level, which is the geode. Okay, so here you will click on this drop down shadow arrow here, then you choose on grid. So then therefore the next thing is to come to type. Okay, you click the drop down shadow arrow here, then you click the geode model. This is a geode model that has been set up on the software. In subsequent video, when I show you how to download and install the software, I am going to show you how to impute this into the software. Okay, so you choose the geode model of interest, then this you do not need to do anything, and this nothing to do. Then lastly, you have to save this, because this is no longer UTM WGS84 zone 31, this is now UTM MENA zone 31. Alright, so you are going to rename this coordinate system that I have just set up. So you are going to do the same thing for yours. So you are going to rename to UTM MENA zone 31 north. Okay, so that is just how to rename. So remember, you can just put an underscore so that it can be saved perfectly. So underscore, and here as well underscore. Okay, then you click on OK. Please, if you do not get that, you can rewind the video and know how to do that setup perfectly. If you don't get that setup right on the coordinate system, your results will be wrong. Thank you. So the next thing to do is to import your files, your static data. Okay, so you come to import and you click on that. So you come here to import files, you click on that. So either you import as files or you import as folder. So the first thing, let me show you how to import as files. So you click on import as files, then you scroll down to the folder of the static observations. So this is static data. So you import your base first. Okay, so I want to show you how to import as files. So these are the files. Okay, the base files, the observed static data for the base. Then you click on open. So when you see this prompt, you click on OK, no cause for alarm. So this is the base observed files. Okay, now the next thing is to import the rover data. So you go to import files. So let's import as folder this time around. So you select folder, you go to the folder of interest. Then this time around it is rover. You can see rover data. Then you choose the data inside the rover data, the folder inside the data rover. All right, then you click on OK. So I have you click on OK. I have 16 sets of data for the rover. So let's forge ahead as well. When you have this prompt, you click on OK, and boom, that is just my set of observations. So you should take note, your base observed data is expected to have, please take note of this, your base data is expected to have a connection, a linkage to your rover data. All right, so you can see all of these data have a linkage to the base data. That shows that the observation is well observed, is well taken. All right, if any of the data is not linked to the base, all right, it is not going to process. That shows that the time of observations did not synchronize, all right, did not tally. Okay, so you can see all data is linked to the base. So when you are done importing the data, the next thing to do, okay, is to set up your control point. Define your control point. As you can see, all this data, there is no one that is defined as the control point that will be used to process the other unknowns. Okay, so you can see there's a base. The reason why it's a base is because it has coordinates. It has eastings, northings, and height, the elevations rather respectively. Okay, and all these rover, they are the unknown points. So the next thing to do is to come to observation files. You click on that. So here under the observation files, you can choose to rename the points. You can choose to do some other editing, which I'm just going to show you now. All right, so the first thing to do under the observation files, okay, is to delete data that is out of range. What I mean is that this static observation is taken for above 30 minutes. So each rover points, each observations was above 30 minutes, 40 minutes, 1 hour or thereabout. So all observations that you see, the time span that is less than 30 minutes is going to be deleted. That shows that it is due to some little errors. Maybe the battery went off along the way and some other little error from the receiver or from the observer itself. All right, so that's just the idea. So I'm just going to see the time span of each data, then you have to check for yours as well to see which of the data is less than the observation timing. All right, so you can see the first data is 35 minutes. You can see the start time, you can see the end time. So this is 35 minutes, this is 40 minutes, here is 3 minutes. All right, so I'm just going to delete this. So you delete it, any data that is less than the observation timing, the epoch, you right click, then you click on delete, then you click on yes. So you scroll down, this is just 26 seconds, you right click, you delete. Scroll down, this is just 4 seconds, you right click, delete. So this is just 14 minutes, you click on it, you right click, you delete. So this is just 4 seconds, you right click, you delete. So this is 1 hour, this is 6 seconds, right click, delete. So all observations is above and it is within range. All right, so these are my sets of original data, static data observed on site. All right, so the next thing is to scroll down, scroll forward. Okay, scroll forward rather. All right, so here you are going to choose the antenna. If you are not using Tersus receiver, there are other antenna receivers, so you have to scroll to see which is yours. All right, so I'm just going to leave it as the TRS Oscar receiver. So this is Tersus Oscar receivers. This is the equipment, the GNSS equipment used to obtain this set of static data. So you can see here below, the system already automatically dictates this receiver. So this receiver is different from the Tersus receiver, so you can see. So you just leave this the way it is. So after that, you leave this receiver column the way it is. Then here is a very important one as well. So this is the height of equipment that is being measured on site. So when you take your static observation, you are expected to measure the height of equipment. So there are two different measure techniques. Okay, so there is antenna bottom and there is face center. The antenna bottom is where you measure from the point on ground to the bottom of the receiver. All right, the bottom of the receiver, when you use your tip to measure that. Okay, then the face center is where you measure from the bottom of the point, that is the ground point, to the marked edge of the receiver. There is a particular edge that is being marked on each receiver. All right, so you can find that in other textbooks or other online sources what I mean by that. So the antenna bottom, face center are the two measuring techniques. So you have to know which one you measure to, so that you can click on it, then you are to edit the true height. Okay, because this height, they are not going to give you the original height that you measured on site until you come here to edit it. So you are expected to have this detailed, taken and noted in your field book. All right, so for my first receiver here, so you can actually pan down to see the full ID of this receiver. So this is point LSKR 035X. So the height I have on my field book is 1.58. Okay, so you double click on the antenna height, then you edit. So the moment you edit the antenna height, the true height is going to be edited immediately, automatically. So I have 1.58 is in meters. Okay, then for this next AG0PCS, I have 1.53. So that is just how you have to edit for every other one. Okay, so you edit your height of equipment to what it is that you observe on site. So that is just how you are going to edit yours. Okay, except if you are not interested to have a true height results at the end of the day. So, or if you're interested on the height of your rover point, you are to do just the way I am doing right now. So therefore I am done editing for the antenna height. So you should do the same thing as well. So when you are done with all this, okay, the next step is to set the control points. Okay, edit the coordinates of the control point by coming to points. So you can close this, you come to points. All right, so here under points, you are to see and check the receiver ID, okay, of the base. So my receiver ID is LWBCX7P. and you can check the observation time as well. The observation time is longer than every other one, so you can see that under the observation files. So check the time span, so you see the one that is longer. So you can see here below, this is 5 hours time span. So you can see LWBC X7P. That means that the base is expected to stay longer. It's expected to log in static data, log in satellite data more than the rover receivers. Okay, so this is the base receiver for 5 hours. So I'll just go back to the point so that I can set that as my control point that will be used to correct all other rover points. So here it is below here. So when you click on it, you right click, then you click on edit. So here on edit, you will have the point. This is the mark name, this is the code name. You do not need to do anything here. You come to the WGS84. okay, here you do not need to do anything here. All right, the place of interest is the target. All right, so here on the target, this is where you have to correct and edit the eastings and the northings and the height of the base. Okay, the default coordinate is not going to be correct. It's not going to be absolutely correct. That is why you are processing. Okay, that is why you are processing. So here I have it on my Excel sheet inside my folder. Okay, so here it is. So here is the base coordinate. Okay, the base coordinate, I already have it. So I have the eastings, I have the northings, and the height. So this is the correct coordinate of the base. As you can see here, it is just close, but it is not the same. So what I'm going to do is to copy and paste to the respective values. Okay, so my northings is this. So I'm just going to right click, copy, so that I won't do any mistake. So for you to edit this, you click on edit, then you come here, highlight, cancel, then you paste. Okay, so this is the correct coordinate of the northings. The same way for the eastings, you erase that, then let's copy, then you paste. The same way for the elevation. Okay, you erase, then you copy the true coordinates. So this is just the idea. You edit the target coordinate to the right coordinates. Okay, so when you are done editing, okay, you click on apply. So you are going to see it's going to change to the right coordinate of the base. Okay, so when you are done with that, you close. Okay, so the next thing is to right click on this, then you set as control point. Okay, so you click on that, so you can see the triangle icon that shows that this is now a control that will be used to correct all other rover points. All right, so it's not compulsory that you have only one base. You can have two bases. All right, let's say this is your second base. Okay, you can right click and do the same editing, come to target, then edit to the right coordinates. Okay, and still set it as your control. All right, however, I only have one base for my observations, so there's no cause for alarm. So the next thing is to come to control points here. All right, please make sure you are following this video step by step so that there won't be any error or mistake anywhere at all. Thank you. So when you come to the control point here, you are going to see the observed data of the LWBCS7P, which is my base control. Okay, which is my base. So you come here, then you double click on this box. So you are going to see this prompt. You click on this box to check fix WGS84, then you click on this box so that the three of them can be checked. You do not need to do anything here again. All you have to do is to come to this and click on state. So here you can see below, the reason why we are clicking on state is that the state control point can be used in both constraints 3D and 2D adjustments, while the local can only be used in 2D adjustment. So you can see that the state will give us our network adjustment in both 3D dimension and 2D dimension. That is eastings, northings, and elevations, and not just eastings and northings without elevations. So you check on state. All right, so when you click on state, you click on apply. So you are going to see the two box checked. All right, so that is just that. So the next thing is to come and process baseline. All right, come and process baseline. So for you to process baseline, you have to click on baseline here. Then let's see the processing options. Let me just quickly explain some few things. All right, so under the general, you will have the elevation marks. The default is 15, the interval 30, okay, minimum epoch 10, etc, etc. You do not need to do anything here. So I'm going to show you what you have to do under the advanced later. Okay, so let's just process baseline of our observations. Okay, so this, you can see under the project plot, we already have this as a triangle icon indicating a control point. All right, so you have to come to process all, so and click on that so that all observed data can be processed at a time. So you just give it a little bit time depending on how bulky your data is. Okay, so guys, as you can see, the baseline is all done processing. However, there are some baselines that is not yet processed, just like you are seeing on the screen. These baselines that are red is not successfully processed. So you are going to see which one is passed, which one is ineligible, or which one is failed. So for you to see that, okay, you have to come to baselines, then you click on that, so you can see the informations of the baseline. So you can see that the baseline of this is ineligible, even though it is LC fixed. Okay, it is partially fixed. All right, so you can see this two is ineligible. All right, and others is passed and it is fixed appropriately with a very tiny root mean square error. Therefore, in the second part of this training video, I'll be showing you on how to adjust the baseline for it to be passed and fixed appropriately. All right, in the second part of this video, so that this video will not be too long for everyone to comprehend. Okay, so this is where I'm going to stop in this part of the video. Please make sure you hit on the subscribe icon now and turn on the notification bell on this channel, so that you can immediately get notified as I upload the second part of this video, so that you can see how to adjust, okay, manually. This is a major challenge faced by many surveyors and geometricians out there when they have failed process baseline, just like what you are seeing on the screen. Okay, baseline is just from a known point to another known point. Okay, so these are rover points that is going to be processed very soon. So these are baseline. So you can see this baseline is red, this is red, and that is not acceptable. Okay, so I'm going to show you the perfect way to adjust your baseline, okay, accurately without any issue. You are going to find out that everything is going to be passed and it's going to be fixed. Okay, thank you for watching. Make sure you hit on the subscribe icon now and turn on the notification bell on this channel to get notified. Thank you.